Hello, you have tuned into Solving Trigonometric Equations. Well done for choosing a really exciting topic, okay? Solving Trigonometric Equations. So I'm doing this from the Year 12 point of view because the equations I'm going to be solving are quite basic, but I'm going to give you the techniques needed to solve a simple equation involving sine, cosine and tan. Just a word of warning, it's all going to be in radians for you, okay? If you don't know about radians, then just look it up or go back to see some of my other videos, okay? But I'm assuming that you know how to draw the graphs of sine, cosine and tan, all in radians, okay? Ready to go? Right, let's get on with this. So the first up, I've got an example in solving an equation involving sine, okay? Sine. So the equation to solve is sine theta equals 0.6. You've got to work out what theta is. Often you're given an interval in which to give your answers. So here the interval is between 0 and 2 pi. It's the most common interval, okay? But there are other intervals as well. So we've got to solve theta between 0 and 2 pi. So the first thing to do is just get out your calculator, okay, and work out the inverse sine of 0.6. Right, here's my calculator then. So let's just make sure it's in radians mode. Mine is, of course. Then you just do inverse sine of 0.6. And the first answer should be 0.6435 something, okay? So I'm going to put 0.644, and that's to 3 significant figures, all right? So that's the first answer. Now, there's another answer. Why is there another answer? Well, let's just look at the sine graph, shall we? So the sine graph is this. On the vertical scale, okay, I've got 0 up to 1, but I'm looking at when sine theta is 0.6. So that's going to be about there, okay? That's 0.6. Now, if I draw a horizontal line at y equals 0.6, it's getting a bit wobbly there towards the end. The intersection between that straight line and the curve shows you our solutions. So our first solution is here, you see? That was 0.6 something, okay? Our second solution is here. And we need to know how to get our second solution. What we can do is use the symmetry of the curve to get it. So what I'm saying is use the symmetrical properties of this curve to find out what that solution there is. Now the rate at which the curve increases from here to here is the same as the rate at which the curve increases backwards from here to here. Okay? Or another way of putting it, this gap there, this distance, is the same as this distance there. Okay? You may have even come across this rule before, that sine theta is the same as sine pi minus theta, okay? Or if not, you've seen it in degrees. Sine x is equal to sine 180 degrees minus x, okay? I'm just using theta. We can interchange between theta and x, okay? Bottom line is you do pi, subtract that to get your second answer. So let's just work out that is pi, subtract that answer, 2.498, okay? So 2.498. So what I'm going to have to do is I'm going to have to round it to 2.50, aren't I? To 3 significant figures. Okay, happy with that? Good. Right, let's move on to the next one, shall we? So the next one here is a cosine question. So solve cosine theta is equal to 0.3. Again, the same interval. So what I'm going to do is, because I know the first answer is going to give me something, I'm going to just use the graph just to illustrate why there's 2 answers again for this curve, because that is the line y equals 0.3, say, and I'm expecting one answer there. Now that's the answer my calculator is going to give me, and then I'm going to have to do something to work out the next answer, which is about there. So let's work out the first one, shall we? So again, make sure your calculator's in radians. It should be, unless you fiddled with it since, although why would you, in between the questions. So 1.266, so we got 1.2, let's round to the 3 significant figures again, 1.27. There we go. And then what we're going to have to do to work out the second answer? Well, again, we use the same sort of symmetrical properties. That is, the rate at which this graph decreases from here to here is the same as the rate at which this graph decreases backwards from here to here. Or, put simply, that gap, that distance, is the same as that distance there. Now here I'm going to show you the result that cosine theta is the same as cosine 2 pi minus theta. Or put simply, we need to do 2 pi subtract this value here to get our second answer. So if that was 1.26 something, let's just put 1.3 to two significant figures. If I do 2 pi, subtract that, that gives me my second answer. 5.02. Okay, that is a very dodgy looking 5, excuse me. Okay, 5.02. And that's our second answer. Again, 3 significant figures. Okay, right, next question. So you can guess what this is going to be, can't you? Yes, one involving tan, the tangent. Okay, so we've got tan theta equals 2. Okay, and here's the wonderful tan graph. Okay, so first of all, I'm just going to draw in the line y equals 2. Now, unlike sine and cosine, the values of tan theta will just increase up and up and up way towards infinity. Okay, so you can do the inverse tan of 2, no problem. Okay, let's just do that then on our calculator. So inverse tan of 2 gives me 1.107. So that's my first answer. 1.1. I'm going to put 1.11. 3 significant figures. And how do we get to our second answer? Well, the tan graph is actually a little bit more straightforward. Because the period of this graph is just pi radians, we can just add pi to it. So what I'm saying is, notice how the solution here on that part of the curve matches exactly, geometrically, exactly the same as that solution there. So the curve is increasing from here to here. It's the same as the rate at which it increases from here to here. Or to get from this part of the curve to that part of the curve, you just add on pi because it's another cycle of the curve. It's another period, okay? So here I'm just going to quote this result for you, that tan theta is the same as tan pi plus theta. So I'm just going to add on pi to that answer. Okay, so add pi and answer 4.248 something. So 4.25 to 3 significant figures. Okay, and those are some really simple examples. All right. And let's just summarise that very briefly for you. Okay, so with the sine graph, when you do the inverse sine of an amount, you've got your first answer, and then you subtract your first answer from pi radians. Okay. With the cosine, when you do the inverse cosine of a value, you've got your first answer, subtract that answer from 2 pi. Okay, and then lastly, with the tan graph, you've got your first answer, then just add on pi radians to get that. Okay. I'm hoping you found that useful. Right, stand by for some more examples. Okay, so this is only a little add-on to the previous section I did. So suppose you need more answers. Suppose your intervals between 0 and 4 pi, or 6 pi, or 7 pi, or 8 pi, it doesn't matter what, okay? But suppose you need more answers. What are you going to do? Well, first of all, get your first 2 distinct and different answers, okay? So we've got those from the previous examples. Then the simple thing to do is just add 2 pi to each of those. That's it. The reason is because this is one cycle of the sine graph, and then it will do exactly the same again between 2 pi and 4 pi. So when it does exactly the same again, see, it'll then intersect here and here at precisely 2 pi more than that. So add 2 pi, you get to here, and 2 pi more than that. So add 2 pi to get to there. Okay, so the simple thing is, once you've got your 2 answers, just keep on adding 2 pi to get as many as you want. Or suppose you need negative answers, suppose it's between negative 2 pi and 2 pi, you just subtract 2 pi because it actually continues on the other side of the vertical scale, doesn't it? On the other side of the y-axis, okay? So bottom line is, once you've got 2 answers, just keep on adding or subtracting 2 pi to get as many as you need. And it's exactly the same on the cosine graph, okay? Got 2 answers there. If I add 2 pi to that, that'll give me 2 more answers. And that will give me more answers in the interval 0 to 4 pi. If I need negative answers, with a cosine graph, it's pretty easy, okay? With the cosine graph, here's a little tip for you. Both negative that and negative that will actually work. Why does that work? It's because the cosine graph is symmetrical about the y-axis, okay? So here you've got the cosine graph. It's actually the mirror image of that on the other side, okay? So basically, any value you've got that's positive, you can make it negative to get negative values should you need to. Okay, and then finally with the tan graph, or this one, the easiest one of all, just keep on adding or subtracting pi. Like I said, you add on pi to get to that one, you can add on pi to get another one, add another pi, add another pi, add another pi, because basically the graph is doing this all the way along. You can see another pi will get you to there, or going backwards, okay, going this way, you just keep subtracting pi to get all the answers you need. Okay, so I'm hoping that gives you a very good summary of what to do when you're doing the inverse sine, cosine and tan. Okay. Right, now you've got the basics done, let's do some more challenging questions, shall we? Okay, so here I've just put 4 equations on this screen here. Maybe you pause the video and have a go at them, and you unpause just to check if you're getting them right. Okay. Maybe you've done that, maybe you haven't, I don't know, okay, but I'm going to go through the answers now, okay. So let's just have a look at this one here first of all. Well, the thing to do is to divide both sides by cosine theta, okay. Why do you do that? Well, I'm going to show you in a minute. So first of all, you write 2 sine theta, and then we're going to divide by cosine theta. And on the right hand side, we're just left with 1, of course. The reason for doing that is because you're going to use the identity. Tan theta is sine theta over cosine theta. So that is 2 tan theta, you see, is equal to 1. And now you can solve it, okay? You've got tan theta is equal to 1 over 2, and then you can do the inverse tan of 1 over 2. Always check your question, because sometimes it's in degrees, sometimes it's in radians, okay? And sometimes the interval is not always between 0 and 2 pi. So I'm going to do the inverse tan of 1/2, and that gives me 0.464. 3 significant figures, and what do we do to get another answer? Yes, we add on pi, okay? So add on pi to get our second answer. So that's going to be 3.61, all to 3 significant figures. That's the first one done, okay? Next, I'm going to look at that one there. So let me just, I'm going to come back to these 2. Okay, it's the advantage of using these wonderful boards. I can do that. So we're going to look at this one. Now, what I'm going to do is I'm just going to put the cosine theta onto the other side, okay? So we've got sine theta is equal to cosine theta. Now, can you see how it's very similar to this, okay? So what I'm showing you is sometimes it's set up neatly, so you can just divide both sides by a particular value or expression. Here, sometimes it's set up so you might need to just rearrange it a little bit first, okay? But we can do the same thing again. We're going to divide both sides by cosine theta. Are you comfortable with just writing tan theta equals 1 straight away? Maybe some of you are, but what we're doing is we're putting that over there to get sine theta over cos theta. That's the same as tan theta. And the right hand side we're just left with 1, of course. And then we work out inverse tan of 1. Now you should be able to do it without a calculator, really, okay? You should know that tan 45 degrees is 1, because a 45-degree angle with the positive x-axis is the line y equals x, and that's got gradient 1, of course. That's a handy way of remembering it. And of course, 45 degrees is pi over 4 in radians. So this time, we can write our answer as a multiple of pi. Now, if it's not possible, then decimals are, of course, what we have to do, okay, and round it appropriately. However, if you can write your answer as an exact multiple of pi or fraction of pi, that is the preferred approach, okay? So we write pi over 4. And then what do we do to get our next answer? Exactly the same as what we did here. We add on pi again. And the done thing is to write it as top-heavy fractions. The preferred way of writing our values is top-heavy fractions, okay? Little hint of that, when you're adding pi to that, just think of adding 1 to a quarter, okay? So a quarter plus 1. And of course, to do that, you can do a quarter plus 4 quarters, which is 5 quarters. So 5 quarters pi, okay? So that's the first couple done. Right, because I've used up all this board space, I did think ahead, and I prepared another board, just in case. So we're going to do these questions next. So this one, and then this one here. So let's do this one first, okay? So the thing to do here is, first of all, you might find it helpful to just rewrite it like this, okay? When you've got a mixture of tan and sine, or tan and cosine, it's a good idea just to write tan in terms of sine and cosine, okay? Now what I'm going to do is I'm going to put this over to that side, okay? So we get sine theta, cosine theta is equal to sine theta, all right? Now, this stage, most students, for the first time, doing a question like this, would divide throughout by sine theta. Please do not do that, okay? Do not divide throughout by sine theta, okay? I'll show you why afterwards, but the preferred approach is to put everything onto one side and then factorise, okay? Factorise is always the best thing to do when solving an equation, okay? So I'm going to put the sine theta to that side, so that subtracts sine theta, and when I factorise, I get this, okay? And how do we solve that? Well, we've got two possibilities. We've got either sine theta is equal to 0, because if that is 0, all of this is 0, or you've got cosine theta, subtract 1 is equal to 0, or cosine theta is equal to 1. It's a bit like when you're solving a algebraic equation, okay? Maybe you'll have something like this, okay? When you're solving that, you've got x equals 0 or x equals 1, similar sort of thing. You've got that equals 0 or cosine theta is equal to 1, okay? Now, why is it not a good idea to divide, okay? Well, let me just give you another example, okay? Suppose you've got something like this, x squared is equal to x. Sure, you can divide both sides by x, okay? You get x is equal to 1. But can you see the problem with that? We haven't written down all the possible answers because you should be able to see that x is 1 or 0. In dividing that by x, you may have not thought about, not contemplated the fact that x can be 0 as well. The thing to do is to bring this onto that side to get this and then factorise like this, x minus 1. And then you're more certain to get both answers. Same with this. If you divide both sides by sine theta, you're not going to think about the potential of sine theta being 0 as giving you a set of possible solutions. Okay. So my advice is always factorise wherever you can, not divide throughout. Okay. So just go write down the answers from these. So obviously, I hope sine 0 is 0, and of course sine pi and 2 pi are also 0. You can get that from the sine graph, of course. And then cosine theta is 1, so you've got theta is equal to either 0 or 2 pi. Okay, so those are your solutions. Yes, I've written 2 pi twice. Yes, I've written 0 twice. That's fine, okay? If you want to write all the solutions in one line and say, therefore, your answers are 0 pi and 2 pi, fine. And you can do that. But my preferred approach is I'm going to write my answers like this because I can see those answers have been generated from sine theta is 0 and these answers have been generated from cosine theta equals 1. Right, I'm hoping you're happy with that. Right, next I'm going to go through this question here. And the first thing I'm going to do is, as with before, I'm going to rewrite the tan theta. So I've got cosine theta is equal to sine theta over cosine theta. And then I'm going to put the cosine theta onto that side. You see, when you're solving equations, you normally want to try and rearrange it so there's no fractions involved. And that's what I'm doing here. I'm putting this over to the left-hand side so there's no fractions. So I've got cosine squared theta, that'll be, won't it, is equal to sine theta. Okay. What to do here? What to do here? Well, the thing is, with an equation like this, okay, you've got two different terms. Here, it's kind of obvious what to do because we had sine theta was common in these two terms, so factorising was the way to go. But here, because they're completely different, you've got to look to another method. And here we're going to use an identity. We're going to use the identity that cosine squared theta is the same as 1 minus sine squared theta. You remember that? That comes from sine squared theta plus cos squared theta is equal to 1. Okay, so 1 minus sine squared theta equals sine theta. Okay, it's getting a bit cramped now, this working, so I'm just going to put this over there a little bit. Again, the advantage of using these boards. And this is a quadratic now, so what I'm going to do is I'm going to put all the terms into one side. So I'm going to put sine squared theta over there. So I've got sine squared theta plus sine theta, and then put the 1 over there as well. Subtract 1 is equal to 0. And that's a quadratic equation that needs to be solved in the same way as a quadratic. These will either factorise, or quite simply they won't. Okay? If they don't factorise, you can use completing the square or the quadratic formula to help you. Okay? You can quickly check using the discriminant whether it factorises or not. If it helps you, you can write it like this: x squared plus x subtract 1 equals 0. If it helps you, and then of course you might feel more comfortable using the quadratic formula on that. Okay, but you don't need to. Okay, maybe you're tempted, you didn't get that far, and you're just contemplating that. Maybe you're going to pause the video and just try and do the rest yourself. If so, then good on you. But as you can see, I just need a bit more board space, so I've just tied it up a little bit. Okay, so here You can use the quadratic formula if you want, that's what most people go for. Let's do something different, let's complete the square, shall we? So if we complete the square, we have x plus a half all squared, subtract 1/4 and subtract 1 equals 0. If you're not happy with that, then how on earth did you get this far, in all honesty? How did you get this far in maths if you didn't understand what I've just done there? Okay. But expand the brackets, you get x squared plus x plus 1/4. So subtract 1/4 and then subtract 1. So you've got x plus a half squared. I'm going to put this and this on the other side, and that's going to be 1/4 plus 1, it's 5/4. Okay. And then square root both sides, so x plus a half. Oh, my writing suddenly got a bit weird. X plus a half is equal to, and we're going to do the square root of 5 and the square root of 4. Do not forget the positive or negative. Okay, that's something else that is sometimes left out by mistake. Okay, when you square root both sides, you've got positive or negative. Okay, of course, using the quadratic formula, you've got the plus minus bit in the formula itself, haven't you? And that's sometimes why some people prefer it, so you are guaranteed to get both those possibilities. Okay, but here we've got to have the plus or minus, and then we've got x is equal to negative a half plus or minus root 5 over 2. So well, that's negative 1 plus minus root 5 all over 2. Okay. Now I'm just going to do a quick check on that because I've got a suspicion one of those is not going to be possible. So I'm going to do negative 1 subtract root 5, okay, and then divide that by 2, work out as a decimal. Yes, that's negative 1.61. Okay, negative 1.61. Of course, when you're doing the inverse sine of a value, it's got to be between negative 1 and 1. So when you do the inverse sine of negative 1 subtract root 5 over 2, it's not going to work, okay? So the only solution is going to come from sine theta. So notice I put sine theta back into it now because that's what we're doing. Remember, I just put x in there to make it easier for you to follow. So sine theta is equal to this. We're only going to have negative 1 plus root 5 over 2 as a possibility there. And if you check with that, negative 1 plus root 5 all divided by 2. And yes, that's 0.618, you see. And so you can actually do the inverse sine of that, okay? So we're only looking at solutions for these, okay? The other ones are just going to not generate any solutions. I can just about squeeze it in here, I hope. So I'm going to write theta is equal to, so first of all, inverse sine of negative 1 plus root 5 over 2 gives me 0.666. That's kind of interesting, isn't it? Okay, it does go on, but yeah. When I round to 3 significant figures, it's 0.666, it's 239 incidentally. Or an alternative answer is going to be, what do I do? Yes, I subtract that from pi. So pi subtract the 0.666, and that gives me a less interesting looking answer, but it's the next answer, 2.48. Okay, all 3 significant figures, of course. Okay. Right, I'm hoping you found those examples helpful to you. All right. All right, let's do a very different type of example, shall we? So here, cosine 3 theta is equal to 0.766. And we're going to solve this in the interval between 0 and 2 pi. Now, first of all, just contemplate how many answers you think there will be. How many answers do you think there will be? I'm just going to draw a cosine graph for you, okay? So here's a cosine graph, quick sketch of it. So that's between 0 and 2 pi, you see. Okay, that's the graph y equals cosine theta. So what about the graph of cosine 3 theta? What does that look like? Well, the 3 theta means that the period is now going to be just 2 pi over 3 instead. This will be 1/3 of the original period. Remember the transformation, f of ax, where the transformation is multiplied by a factor of 1 over a in the x direction. So if you multiply by a factor of 1 over 3, 1/3 in the horizontal direction, then what happens is the graph gets squashed together. So instead of 2 pi, it's now going to be 2 pi over 3. So that means I can fit in another cycle of the graph up to 4 pi over 3, and then another one up to 2 pi. Okay, so that is the graph of cosine 3 theta between 0 and 2 pi. Now if I put in the straight line 0.766, can you see how many solutions there are? So there's the usual 2 when the interval is between 0 and 2 pi with cos theta equals something, but with cos 3 theta, I'm going to get another 4, okay? So it's as well to consider you could get 6 possible answers with a question like this, okay? Right, let's just have a look at this. So the thing to do is to do the inverse cosine first. And when you do the inverse cosine, you're left with 3 theta, don't forget, because you're undoing cosine by doing the inverse cosine, so you're left with 3 theta on the left-hand side. Now let's work out what that is. So calculator time, again, just check it's in radians. Inverse cosine, 0.766 gives me 0.698. Okay, so 0.698 something. All right. Now I'm going to put dot 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 there because this is not the final answer. Okay, the final answer will be when we divide everything by 3, won't it? Okay. Now the thing to do is write down as many possible answers as you possibly can before you divide by 3. The reason is otherwise you just might get it wrong. Okay. Thing is, when you do the inverse cosine, you've got to consider all the possible answers you can get. Now, if you remember from previous examples, once you've done the inverse cosine to get your first answer, you can subtract that from 2 pi to get your second answer. So 2 pi, subtract that, and it gives me 5.58. Okay, so what on earth is all that about? Okay, I don't know. 5.58 something. Okay, so that's my second answer. Okay. And then I'm going to add 2 pi to each of these to get all my other answers. Okay. Why is this happening? Well, don't forget, despite the fact you've got cosine 3 theta, your graph operates on cosines and inverse cosines. And so when you do the inverse cosine, it's looking at your domain between 0 and 2 pi. And so the first answer I'm getting is that one there, you see. And the second answer is that one there. And I just need to generate even more. Okay. So let's just get rid of that. So the thing to do is just keep on adding 2 pi to each of these answers, okay? So if I add on 2 pi to this answer here, 2 pi to that answer there, 2 pi, 2 pi, 2 pi, okay? So if I add on 2 pi to that, okay, plus 2 pi, I did that one first because that was in my calculator display, I'll get 11.868. And if I add on another 2 pi to that, plus 2 pi, you're going to get 18.15 something, okay? Now we'll go back to that. I'm going to get the exact value again, inverse cosine of 0.766. So 0.698, add 2 pi to that, and I'll get 6.98. And then add another 2 pi, I'm going to get 13.26 something, okay? So those are the 6 possible answers for 3 theta. Now to work out theta, I'm just going to divide each of these by 3, okay? And that is it, all right? So if I divide each of these by 3, I get my final answers, okay? Job done. Now I've still got that in my display, so what I'm going to do is I'm going to start off with that, I'm going to divide that by 3, okay? And I get 4.4, and I'm going to round this now to 3 significant figures, okay? And then what I'm going to do is I'm going to select that answer there, so that was 6.98. If I divide that by 3, I'll get 2.33 when I round that, and then I'll get this answer there, and that was 0.698. If I divide that by 3, I'll get 0.233. Okay, so that's those ones done. Okay, next I'm just going to get that answer, 5.58, divide that by 3. Okay, so that's 1.86, and then this answer there. So I'm just quickly getting these. Once you've done this a long time, you can probably do it as quickly as I can. Okay, I won't talk you through exactly what I'm doing because it might just confuse. I'm just basically getting that answer again and dividing that by 3. So that's 3.9. I've got to round it to 96. Maybe I'll just talk you through what I'm doing to get the next one. Okay, so I'm going to times that by 3 to undo it. Okay, and I'm back to that. If I add on 2 pi, then I'm back to that, and now I divide that by 3. I'll get 6.05. Okay, so those are my 6 answers. Okay, yes, normally I'd like to write them in a long line. I've just set them out this way so you can make it So it's easy for you to see, basically. Otherwise, I'm going to be doing this along the board, and it's going to go behind me, and I'd rather you see the answers just there. Okay? So that's the first one. All right. I've got another one coming up for you in a minute. Okay, I realise it wasn't quite a minute for you, but it was for me. What was I doing in that time? Right, so in the interval this time between 0 and 360 degrees, okay, solve this equation here. What I was actually doing, that means I was just changing my calculator into degrees mode. I suggest you do the same. So just note that this one is in degrees, okay? I just thought it'd be a little bit different because that's what you've got to be able to do in A-level maths as well. And we're going to solve this. So this is kind of similar to what we had before, in that we can just divide both sides by cosine 2 theta this time to write 2 sine 2 theta over cosine 2 theta is equal to 1. And then we're going to use the identity that tan 2 theta is the same as that. So you have 2 tan 2 theta is equal to 1. And then, of course, you can write tan 2 theta is equal to a half. And then we've got to solve that. Okay. How many answers are we expecting? We're expecting 4 this time. So generally speaking, when you've got something like this, tan theta equals a number. Doesn't matter what it is, okay? Let's call it P for just a constant number, okay? Normally expecting 2 answers within this interval, okay? But when it's tan 2 theta is equal to something, the number of answers are doubled, okay? And when it's tan 3 theta, as we saw with the previous example with cosine 3 theta, the number of answers are trebled. You get 6 answers. And same again. So tan 4 theta, so the number of answers multiplied by 4. It's a generally handy way of looking at it, isn't it? It's because this tan 2 theta graph, it's now been stretched a factor of a half. So you can fit 2 normal cycles into the period, into the interval of 0 and 360 degrees. Okay, so we're looking for 4 answers this time around. Usually a good idea to know roughly how many answers you're expecting before you answer the question. So we'll do the inverse tan of a half first of all, to make sure your calculator is in degrees mode. As I said, mine is, just checking that. So inverse tan of a half, so 26.565 something, okay, is my first. And then what do I do to get the others? I add on 180 degrees this time. Okay, that's what we do with the tan graph. Just keep adding 180 degrees. That's 206.56 something. I'll add another 180, and that gives me 386.56 something, and add another 180, and that's 566.56 something. I'm just going to put the degrees sign there because we are in degrees and it's appropriate to write degrees. Okay, and then what we're going to do is just divide everything by 2, and then we're done. Okay, so inverse tan of a half, just get that up again. Divide everything by 2, so divide that by 2. So you get 13.3 when rounded to 3 significant figures. Okay, then divide that by 2, then divide that by 2, then divide that by 2. Now look, if you're comfortable with doing this, instead of dividing everything by 2, just add 90 degrees to all your answers. Okay, because obviously difference between each of these now is 180 degrees. Okay, so instead of doing that plus 180, then divide by 2. If you divide by 2, just add 90 degrees to that, okay? And that will give you your answer. So that's 103 to 3 significant figures. And of course, you can check that that is half of that, okay? Then add another 90 degrees. So that gives me 100. I'm sorry for using my calculator for 90 plus that. Yes, I can do it in my head. I like having the decimals as there as well. So 193 degrees. And of course, you can check that. Okay, and then the next one, no, I don't use my calculator, but you're probably doing it as well, so I'm just doing it at the same time as you. Okay, so 283 degrees, and yes, you can see that divided by 2 is 283 degrees. Okay, so there we go. Those are our 4 possible answers for that one. So, next example then. So, sine theta plus 60 degrees is equal to 0.3. Solve it in this interval. Maybe you pause, have a go, then unpause it, see how you get on. Now this one, because it's sine something equals 0.3, the first thing to do is the inverse sine. So inverse sine both sides, you're left with theta plus 60 degrees, and we just work out what the inverse sine of 0.3 is. Okay, so check your calculator in degrees mode for this one. So inverse sine 0.3, and 17.45 something, okay, is what we get for that one. And as soon as you do the inverse sine, get another one, okay? So we do 180, subtract that answer, and that's also going to be 162.5. Terrible. 162.5. Terrible the writing on my board sometimes. Okay. Now there's only going to be two answers because the angle here is just theta, so it's not 2 theta or 3 theta. So all that's happened is the graph has just been translated left 60 degrees. Okay. So there's two solutions generally to our equation here. But notice when you subtract 60 degrees, okay, from this, it becomes negative, doesn't it? Okay, because you want to do 17.4 subtract 60 to get theta. Well, that's no good. You don't want an actual value of theta to be negative. But hang on, I did say there's generally two answers for this. So what to do? Well, find another one, okay? If we're not going to use that one there, find one more than this, okay? So we can find one more answer. What to do? Apologies for the bell. We just add on 360 degrees to that. Remember, you can keep on adding 2 pi in radians or 360 degrees to each of these to generate more answers. So we're going to add 360 degrees to that, okay? And then we're going to subtract 60 from all of them, okay? So subtract 60 from this, negative as I said, so we'll just cross it out because we don't need that anymore. This will subtract 60, so we have 102 point, let's just check, yeah, it's 0.5 degrees. Maybe 103, I've done it now, I've put it one decimal place, okay? Sorry, bit of inconsistency there. Okay, I'll just round these to one decimal place, okay? And then subtract 60 from that, that'll be 317 point, I better just check that, okay? Beg pardon, so I've got to get the thing up again now, so that's, 0.45, yeah, so I'm glad I've checked. So that's going to be 317.5, okay, when rounded to one decimal place. Okay, it's always a good idea to check the rounding there. And you can see both our answers now are within the required interval. Okay. Right, next equation. 2 cosine squared theta minus cosine theta minus 1 equals 0. Right, so hopefully you can see straight away that's a quadratic. Okay, so remember I showed you one of these earlier where you could, if you wish, write it in terms of x. And if you want, you can write it as 2x squared subtract x subtract 1 equals 0, if it helps you. Or you can just go straight into trying to factorise that term without the need for writing this. Okay, that's what we'll go for. So I'm going to write 2 cosine theta, and then in the other bracket it's going to be cosine theta, because obviously that's where the cosine squared theta comes from, times by 2, and then you're going to have 1 and 1, so to get that as negative, I'm going to want to have it like this, aren't I? Okay, so it's going to have to be 2 cos theta plus 1 cos theta minus 1, okay, because the cosine theta minus 2 cosine theta gives me that. So you can either use this approach. If you do, that's fine. Just remember to write it in terms of cosine again, okay? Because really, this is what you're getting credit for working out what cosine theta is. And from here, you've got two possibilities. You've got either negative 1/2, or you've got cosine theta is equal to 1. And then you've got to work out both sets of possible answers, okay? So from this one, you've got cosine theta is negative 1/2, so you've got to work out that one first of all. Just check whether it's in degrees or radians, so obviously degrees, and set your calculator up and do inverse cosine of negative 1/2, okay? And you get 120 degrees. Okay, so that's your first answer. And then second answer, what do you need to do? Yeah, you need to subtract that from 360 degrees. Okay, so 360 subtract that gives you 240 degrees. Okay, I forgot to mention, but when you do these, you can always check your answers by typing in cosine 240 degrees. You should get negative 1/2 if you're a little bit unsure. Then with this one, you've got cosine theta is 1, so the inverse cosine of 1 is 0, and the other possibility is 360 degrees. Okay, so that's our solution to that. Okay, if you want, some people like doing this, you write all your answers in numerical order: 0, 120, 240, 360. I just don't. As I'm sure I mentioned before, I like seeing how the answers have been found from the work in here, either that or that. Okay, next one. So sine squared theta minus 30 degrees is equal to 1/2. Okay, sorry, the half doesn't quite come out as well there, does it? But yeah, trust me, it is 1/2. Okay, so the first thing to do is to square root both sides, because you've got sine squared something is equal to 1/2. Okay, remember the notation for that? That means you do sine theta minus 30 degrees, then square it, and that's equal to 1/2. So you've got to do the square root of both sides. But when you do that, do not forget plus or minus, the positive negative symbol. Okay, so plus or minus 1 over, and it's going to be root 2, isn't it? Okay, and then you do the inverse sine. So when you do the inverse sine, you have theta minus 30 degrees is equal to, and then you can do the inverse sine of 1 over root 2, then the inverse sine of the negative 1 over root 2. So what I'm going to do is, for inverse sine of positive, oh, it wasn't rubbing out for a minute, was it? For positive 1 over root 2, I'm going to do that first of all, and then I'll consider afterwards the case when you've got this is equal to negative 1 over root 2. And I can just show my working separately in each case. So this one here, 1 over root 2, maybe you can memorise that. Maybe you remember that sine of 45 degrees is 1 over root 2, or root 2 over 2. So the first answer is going to be 45 degrees. And the next answer, subtract that from 180, so that would be 135 degrees. Okay, let's just check. When you add on 30 degrees to get your final answers, okay, we'll get 75 degrees, or we'll get 165 degrees, and that ties in nicely with that. Okay, and then this one here, so we need to do the inverse sine of negative 1 over root 2, so theta minus 30 degrees, and that's going to be negative 45 degrees. Check it in your calculator if you wish, but it is negative 45 degrees. Now with that, of course, when you add on 30 degrees, you'll still get a negative answer. So just bear in mind, that's not going to give us one of our final solutions, is it? Okay. The next answer is going to be 180, subtract that. Now when you subtract that from 180, you get 225 degrees. That's going to be one of our solutions, isn't it? Okay. And the other answer we're going to find by adding 360 degrees to that. Okay. Remember, you can keep on adding 360 to either of these to get as many answers as you need. So 360 plus that is 315 degrees. Okay, I'm kind of running out of space. So our answers are theta equals, not that because it's negative 15, but this, 255 degrees. And the next one, 30 plus that, 345 degrees. Okay. Well, hopefully you're happy with that. That's it, all done. Okay, that's my video on trigonometric equations. All you need to know to be able to solve trigonometric equations in your first year of A-level, AS Maths. Okay, hope you found it useful. Okay, I'll see you again soon. Bye-bye.